All right, guys, so today we are doing another problem-solving station with word problems. We're going to build on the techniques we learned last week. Does anyone remember we learned 3 different techniques? Does anyone remember what they were? We had hit the quan, the cube method, and sketch it out. Those ringing a bell now? Okay, great. So what I want to do is get you guys set up on these problems so that you can solve them on your own once we've worked out the different techniques we talked about. So on the first one, I'm going to use the cube method. Does anyone remember what that stands for? C is circle the numbers, underline important information, box the question, and eliminate unnecessary information. Excellent. So on this first problem, it says, at the 2005 World Exposition in Aichi, Japan, tiny moo chips were embedded in the admissions ticket to prevent counterfeiting. The moo chip was developed by Hitachi in 2003. Its area is 4 squared times 10 to the negative square millimeters. Simplify this expression. Okay, so if we are going to circle the numbers, I'm going to go ahead and start doing this because these are actually the only numbers we care about in this. This number we don't care about, this number we don't care about, because those are just years. Those are going to become part of our eliminate information thing. That's just extra words they're giving us that might trip us up. So the only numbers we care about are 4 squared and 10 negative squared, okay? Now, if we are going to underline important information, what would some of that important information be? It's area, right? And then what we're being asked to do, simplify this expression. Now in our next step, if we're going to box the question, that's going to be simplify this expression. That's what we're being asked to do, right? Is to simplify the expression. That means that anything we haven't done in color, we can just cross out because it doesn't matter to us, okay? Excellent. So, that question is all set up for us to then solve. Does anyone want to walk me through the steps of solving it?
4 to the power, so you do it
4 2 times.
4 times.
Squared, so that's going to be 4 times 4 equals 16, right?
Yeah.
So that's our first step. And then we've got 10 to the negative 2. What's the first thing I need to do there? When I see 10 with a negative exponent, what's the first thing I need to do?
So you need to
Do 10
times 10 2 times. 10 negative 2 times, right?
The first thing I need to do is put 1 over 10 squared, which you're right is going to be 10 times 10, which equals?
What? 10 times 10 equals 100.
100. So far we have
1 over 100.
16 times 1 over 100. So if we plug that into our calculators, what is that going to give us? Randy's got a calculator. And remember, when you put it in the calculator, you need to put the parentheses around the 1 over 100. That's what it should look like in your calculator.
I didn't have that with the new, but she went crazy about it. She said, no, 1 over 100. Let's get everybody 19.
What you getting? I'm going to go ahead and help you out.
25.
It's going to be 0.16 because when we multiply 1 over 100 is saying 1/100. So if we look at that in decimals, that looks like 0.01. That's 1/100th in decimal form. So if we multiply that times 16, we're going to get 0.16. Now the only thing we need to remember, because we have a word problem, is that usually our answer is going to include some sort of measurement or some sort of activity. So this answer is actually going to be 0.16 millimeters squared, which we know because we boxed the answer and that's what it was asking us. So this is our simplified problem on this one. Excellent. Does anyone have any questions on that, or can they follow that one?
They gave me 425. I don't know what they got. I just put the same
Let's see,
thing.
I'll show you in the calculator. Because it's a fraction. That's what fraction bar means, is divided by. Okay, does everybody understand this step that we just went through? Are we ready to move on to the second one? This next one I'm going to set up for you, but you guys are going to solve. We're going to do that on 3 and 4, okay? So, what method should we use on this next one? Should we do hit the quan?
Yeah.
Okay.
Hit the quan.
So when we hit the quan, the first thing it's asking us is what is the question asking, correct? So when we read this, despite their name, northern yellow bats are commonly found in warm, humid areas in the southeast United States. An adult has a wingspan of about 14 inches and weighs between 3 times 10 to the negative third power and 3 times 10 to the negative second power ounces. Simplify these expressions. So what is the question asking us to do?
We gotta,
It's asking us to simplify these expressions. Speaking of these two expressions, right?
Yeah.
Now when we go to underline important information, what would some of the important information in this be?
3 parentheses 2.
So do we care about the 14 inches? Is that important to us?
No.
We only want to simplify these expressions. So really, that's all we need to know is those two numbers to simplify, correct?
Yes, ma'am.
So that means that the rest of this doesn't matter at all. We don't care about that information.
Yes.
So, how do we simplify these expressions when we see a negative exponent? The first thing we're going to want to do, this is the A part we're doing the answer the question. The first thing we're going to want to do is say 2 to the negative third power. How do we simplify that in the first place?
We do.
What did we do over here?
We do 2, 3 times? No.
What's the first step we need to do?
We put 1
over 2 to the third, right?
Yeah.
Who can use a calculator and tell me what 2 to the third is? It's how, I'm sorry, what? 8? Thank you. 1 over 8 times 3 is our first expression. Now our second expression, 3 times 2 to the negative second power, we're going to do the same way, correct? So to get the negative exponent out of 3 times 2 to the negative second power, what do we do first? We drop it the same way, right? We're going to say 2 to the negative second power equals 1 over 2 squared, which is going to equal 1 over 4. So now the expressions we have, if we rewrite this, I'm going to rewrite in black, is 3 times 1 over 8 and 3 times 1 over 4. So all we have to do is plug those into our calculator. And we're not doing anything with those two numbers, we're just simplifying these, right? This is all we're looking to do is simplify. So we're going to end up with 2 answers on this problem. Who can plug it into the calculator and tell me what that is? We don't even need to plug it into the calculator if you really look at it, guys, because look, This is 3 over 1, 3 over 1. 3 times 1 is what? 3. 1 times 8 is what? 8. There's one answer. 3 times 1 is what? 3. 1 times 4 is what?
4.
Excellent. So those are our simplified numbers, getting them out of the negative exponents.
You said simplified.
Simplified. I don't know, I must be hungry. Okay, so going on to numbers 3 and 4. This says on number 3, Sarah is using the formula for the area of a circle to determine the value of pi. She is using the expression AR to the negative second power, where A equals 50.265 and R equals 4. Use a calculator to evaluate Sarah's expression to find her approximation of the value of pi to the nearest thousand. So we've got a lot of extra information in here. Thousands, that's what I said. So that's something that's important, right? We are using a calculator to evaluate Sarah's expression to find her approximation of the value of pi to the nearest thousand. So all of that is important information we need to know. That's the question we're being asked, right? So everything in red is stuff that we want to answer. Now the only numbers we really need to worry about are the AR to the negative second power, right? And what you have to remember is this is A times R to the negative second power. So we already have the value of A. A equals 50.265. And R equals 4. So since we know that it's to the negative second power, what is that number going to look like? Instead of it being 4 to the negative second power, what is it going to look like? What do we do when we have a negative exponent?
1 over 4.
1 over 4 to the second power. Excellent. 4 times 4 is what?
16.
16. So this is what we're going to plug in our calculator. That's as much as we're going to do on this problem. I'm going to leave it for y'all to answer.
Oh,
it's so rough. Do not forget that we need to know to the nearest thousand. So how many places is that going to be? First point after a decimal is tens. Second point after a decimal is hundreds. Third point after a decimal is thousands. So we want 3 places after the decimal. Excellent. This last one we're looking at, they give us the numbers again. So let's look at the answer, or the problem. The volume of a freshwater tank can be expressed in terms of x, y, and z. Expressed in these terms, the volume of the tank is x cubed times y to the negative second power times z liters. So liters is something we're going to want to know, right? Oops, what am I doing here? What just happened? Liters. And here is our formula. Determine the volume of the tank if x equals 4, y equals 3, and z equals 6. So, if x cubed, do we need to do anything to that or just plug in the number? Just plug in the number, right? So x is 4, that's going to be 4 cubed times y to the negative second power. Y is 3, but how do we get rid of that negative in the exponent spot? We're going to say times 1 over 3 to the second power. So let's put a parentheses here so we don't forget to put that in our calculator that way. Times 6. That's how we set that problem up, because it told us right here what our x, y, and z are going to equal. So I'm going to leave that for y'all to plug into the calculator. We'll look at the very last part. This one's kind of an easier one because they only give us one thing to look at, and then we are answering test question style. So let me read you the whole thing. Allison has an interest in entomology, the study of insects. Her collection of insects from around the world includes the 4 specimens shown in the table below. So here's our table. We've got 1, 2, 3, 4 specimens. select the best answer. So then we have 3 questions we're answering. So if we look at number 5, it says cockroaches have been found on every continent, including Antarctica. What is the mass of Allison's Madagascar hissing cockroach expressed as a quotient? So if we look at the hissing cockroach, it's our last one. It says 5 to the negative 3rd power kilograms squared. If we look up here at A, B, C, and D, which one of these answers is the correct way to express 5 to the negative 3rd power? I can honestly immediately cross this one out, right? Because I know that it's going to be a 1 over.
It's on A.
It's A?
Because it's a negative.
Are we sure? Have any of ours up here had a negative?
Nah, B.
B, exactly. And why is it B, Jadarius?
Slash it. Because we slash that 8.
Because 5 to the 3rd power is 125, and we know that when it's a negative exponent, we're going to go 1 over. So together we're going to underline the important information of the last 2 questions, and then y'all will be in charge of answering them on your own. So many giant wettas are so heavy that they cannot jump. Which expression is another way to show the mass of the specimen in Allison's collection? I don't know what that is either. I just know that it's one of the informations that I'm given, so I don't really care what it is.
Is it wet?
It could be an elephant for all I care, but it's not. It's a bug of some kind. It's an insect. But all we want to know is which expression is another way to show the mass of the specimen in Allison's collection, and we're talking about the giant wettas.
Weta. That sounds like it.
In number 7, scorpions. So we're talking about the scorpions. They're closely related to spiders and horseshoe crabs. We're just going to cross that out because we don't care. And we don't want to get confused by more insects. We just want to know about the scorpions. What is the mass of Allison's emperor scorpion expressed as a quotient? That's all we're looking to answer. So I'm going to leave y'all to answer numbers 3, 4, 6, and 7 on this worksheet. And just raise your hand if you have any questions.